Thanks for joining me today. And shouldn't be too long. And what I want to do today is go over our product Maple, but really from the lens of how it serves as a tool for all things calculation management, specifically for engineers who, as many of you know, whose job it is to make a series of decisions and to keep their entire process organized and to do it really in the most effective way. So at its base, the way we look at it is that engineering is making decisions, and it's making good decisions. And there's a whole bunch of different decisions that need to be made in the right order. So when you're going through a project, there's design requirements to look at. The list goes on in how you organize yourself to approach designing a product. And contained within all of these, really, there's some valuable intellectual property in every step here. And this kind of intellectual property can often be overlooked. So to think about the challenges of actually managing the content of those decisions, why they were made, and why that intellectual property is so valuable, you could think that maybe the requirements could change for your design. There could be personnel changes, innovations may happen. The list sort of goes on, and really this is just to highlight that the intellectual property contained within your organization and your engineering design team, it isn't always explicitly identified and organized in a way that ensures that you can use it and reuse it over time. So to take one specific example, if some personnel are to change in your department, some engineer moves on, retires, or what have you, this can end up posing a pretty significant problem for almost any engineering team. If you're looking to continue on with a project, you might be a little bit concerned about who made the decision that you're trying to now replicate. You're not even quite sure what base assumptions were used in a certain design choice, and that can be often just locked away in the head of that engineer who had left the team. You want to make sure that they had considered a variety of variables that pop up in your mind, but you're not quite sure if those are factored in. And then, of course, if you have some amount of reliance on spreadsheet tools, which work well for so many things, there could be just a dreaded parameter somewhere that isn't really documented. You're not sure why it's there, but you definitely want to make sure that you continue to include it because you don't want to run the risk of breaking what was already created. So it's really important to manage your calculations well, because if you don't, there's really these slowdowns at every step of an engineering project. There's these spaces where you hesitate, you wonder, all these questions, and not only can it slow things down, but it can just pose risks for errors down the road. So there are common ways in which a lot of engineers go about designing their products and making all of their decisions. Of course, at the end of the day, most people will have some sort of paper notebook where they're jotting down all of the math and all the calculations at play. They'll then take some of that. So often, people will use spreadsheets, which are a great general purpose tool, and they serve their function in so many ways. And then to take things a little more methodically, by scripting some of these design choices out, it'll allow them to execute faster, be more repeatable. But there are certain ways that these tools can fall short, and you can use all of these tools well if you understand their limitations. But more often than not, you can sort of fall victim to just over-relying on these tools and not recognizing when it might be time to use something a little more methodical and complete. Paper notebooks, they're hard to update, they're hard to organize, they're hard to pass on. Like we said with that mysterious parameter from before, it can be really hard to document and organize a spreadsheet in a way that you could just pass off and have all of the explanation and the rationale there actually move on. And then for scripting, same thing. There could be a commenting issue where you don't really know exactly what the script is doing. So it could be just hard to know if you can use this again for the next part, for iterating on your design. So there's just a lot of ways these tools can fall short. And if you're going to take your process seriously of managing calculations, there's got to be a better way. And we think that better way is by using Maple. And the way we see it is Maple, it's been around for about 30 years now. And more and more we see it as, and the way we design it, is to allow you to treat your calculations like a real, valuable, structured asset. And that ends up having a lot of implications to how we've designed the software. It's going to allow you to track, to validate, and to reuse calculations without all that ambiguity that we were talking about before. Things are really well organized, and the document interface is an exceptional way to keep everything fully annotated, which ultimately this is going to help prevent all those redundant calculations that we had talked about. All those little slowdowns where maybe you didn't exactly know what the rationale was. By having these things laid out with sort of a fully documented environment that also has all your live mathematics together, can really help reduce all that redundant work. And something that we've been especially developing within Maple is a way to get these calculations and tools out across your organization. So there are free Maple players. There are ways where you can do some calculation work, and you may need to share that across a team. And you can deploy these worksheets, and not only is it fully documented, but at the same time it can be executed and it can be inspected by anybody in a fairly easy manner. So I just wanted to take just a few minutes and go over a couple different features of Maple that would appeal to engineers. And this will be fairly high level, sort of to give you just a base understanding. So one thing I'd previously touched on before was that, sure, in many ways, Maple is, at its core, it's a symbolic and numeric computation engine. It's just a one-stop shop for whenever you need to do some sort of mathematical work. But what really sets it apart is it's a fully featured document interface. And what that means is you are going to have all the tools that you're used to from a word processing environment. And that's going to be helpful for reporting, for keeping your own thoughts clear, for doing some of your own, just sketching out the problem and scoping it out. But it's got all the mathematics in a live fashion that you can just kind of slip in right throughout it. So it's got kind of the best of both worlds in doing your scratchpad math, but also keeping yourself and others organized along the way. That means that all the mathematics that you actually write in, it looks just as how you would write it, and it's impressively easy to actually input. So you'll find yourself just inputting your mathematics that looks as how you would write it on a piece of paper, with a whole bunch of different sort of palettes and options to just make it as simple to put in as really as you would expect. You're not beholden to some sort of 1D programming interface to figure out how to put your math in. And then to really flesh it out, all the different plots and pictures, you want to bring in some graphics to help show a visual interpretation of your project. All of this can come right on board. And then just to get into a bit of the depth of it all, sure, it's great that you can have this amazing document interface with all the live mathematics on board, but there's so many built-in functions within Maple specifically designed for engineers. There's thousands of them, actually. So these are things that maybe if you're using a spreadsheet tool, you might have to input that function manually, get a larger formula inputted. But with Maple, there are so many different toolboxes we have and so many just built-in functions where if you need to do, say, some sort of Monte Carlo simulation and you need to do some analysis there, these are things that are already built in and allow you to actually just kind of click through with a mouse and bring your data set in. So for so many common engineering tasks where you maybe have that like outdated spreadsheet that you've been used to using, these things are built right into Maple. And then you can actually wrap, like I said, that with that document interface, you can just organize that so cleanly where you didn't have to do that much work. You can get the answers you need, and then you can pass that off to other people in your team. So it makes so many bread and butter engineering problems really tantamount to the click of a mouse. And we've had so many customers switch from spreadsheets to only a few lines within Maple. So it can really save a lot of time that way. And again, from a perspective of, you've created this great Maple worksheet, but you know that that's going to need to get in the hands of other people for whatever reason. One way that you can do that without putting it in the hands of other people, but say for other people working on your project who might need a more universal format for the work you've done, we can end up generating code within Maple for a variety of programming languages. It's essentially, you name it, and we can get executable code out so that you can then plug that into the rest of your workflow. On the flip side of that, we can import data from all different sorts of data sets. You can import pictures, audio files, whatever kind of information that you need to process. We can take that on board and we can work with that. So the export and import here is really versatile. You'll find there's no problems connecting this to whatever tool chain you've currently got working. And like I said earlier, we've got what's called the Maple Player, which is a free standalone program that allows other people to take your Maple worksheets and they can run them for free, and they can modify a whole bunch of different variables within that worksheet. And this is a really easy way to share work across your team, your organization, or even to customers if you want to show them perhaps some set of functional requirements or trade-offs in the project that you're working on. You can give them a really clear understanding with just a free Maple Player. So as we move towards the end here, just wanted to bring up two stories of some customers we've worked with and how that was all sort of working for them. This particular success story was from Hitachi Truck Manufacturing, and they just needed a better tool to do some optimization and to plug into their reporting structure. So they had identified, like we said earlier, a bunch of these small slowdowns, and they wanted a better way to kind of clean these up a little bit and to have a more efficient process. One of the big things that they were doing was a lot of just kinematic work and stress and strain calculations for these truck chassis. And in their initial stage, they had historically used these fairly complicated spreadsheet programs, but they were noticing that even the chance of human error at some point for them was becoming just a risk to their business. So they brought Maple on board, and they set up some analysis worksheets with Maple. And we had a whole bunch of built-in functions that allowed them to automatically solve and simplify some of this work. So that cut out just immediately a bunch of the risks involved in human error of what they were doing in their spreadsheets. So that really worked out well for them. And what they had noticed after bringing it on board was, of course, the human error was lower. They were able to reduce some of their larger spreadsheets to very quick analysis within Maple. And they're still underway in connecting that up to their reporting structure more smoothly. But the current spreadsheets they were using, they're more or less already set up in a way where using Maple you could export that now to a PDF, and the reporting becomes a lot more streamlined. So this was just a quick story about how even just by bringing Maple on board, they were able to take their risk down significantly from all the small errors associated with spreadsheets. Our second and last story here is from a diamond mine out in the northern areas of Canada, and they do a lot of throughput analysis, and there's a whole bunch of different parameters involved in their processing process, I suppose, for figuring out really what their throughput's going to be for the diamonds and all the ore that they're mining. So there's really large matrix multiplications at play here, and historically they've taken a whole bunch of time, and once again it was partially due to an over-reliance on spreadsheet tools. So by bringing on Maple, after they had done a bit of decision making around what to do, they were able to remove the reliance on a couple large spreadsheets and actually create an application in Maple that was only a small handful of lines of work by relying on some of our built-in tools. So that was one way in which just bringing it on was able to save them a lot of time pretty quickly. And then another common task that motivated them to bring this on was curve fitting. So they're trying to fit curves to a whole bunch of throughput data, and this is finding it's useful for them getting the probabilities that their throughputs will exceed specific quantities. So the more accurate they can curve fit, the better they're going to have an accuracy on what their throughput actually will be. And this is really important for them to standardize their expectations and yields. And they brought Maple on board because we have a curve fitting package, and this was able to give them insight into just really getting their accuracy better. They could fit curves using a variety of techniques. They could compare them against each other. And this is all through clicks of a mouse and then writing some comments and storing that particular plot and then moving on. The speed at which they could bring more data into their curve fitting and to get better results just is a lot quicker than they would ever be able to do with the spreadsheet tool. And once again, they could take this analysis and then move it on into how they report to the rest of their team, which ends up being a benefit to so many of our customers. So that was a bit about Maple. Like I said, just at a high level, it's sort of a one-stop shop for sketching out your design in the very initial stage. Use it as you would paper and pen. And then as you step through further, it's going to give you all the options to go as deep or as complicated as you need to go on your project, and then all the options to back that out and to prepare that in a way that other people can view it and actually understand what you're doing. So it helps take all those small little slowdowns out from an engineer's design process that we spoke about. Just helps remove this latent element of risk that can exist in so many places when you're trying to develop like a functioning, efficient engineering team. A little bit about us just to wrap up. We talked a lot about Maple this morning. We've also got this other tool, MapleSim, and MapleSim takes all of the mathematical and computational expertise we have, and that wraps it into a physics-based simulation tool for folks that are interested in doing a bit of virtual prototyping of something. And let's say they're trying to size a motor for a new kind of design. MapleSim is a physics-based way to reduce the amount of errors that you're going to have when you actually get to a prototype stage. And then our third wing there is our consulting group, which recognizes that taking on any new software or technique, there's a bit of a ramp-up time associated there. And we've got a whole host of services that'll help really take that down. And some of those services being, will help train you, will help develop the application that you may need within Maple or MapleSim. So if you're sensing some sort of barriers between the way you're doing things now, even if you recognize there are risks associated with it, but the barriers to moving to a more integrated and seamless place, say with Maple or MapleSim, if there exist some barriers there, we've had years of experience removing those barriers for our customers and then equipping them with the tools that they need to be successful going forward.